We are adding 25 milliliters of water, which has hydrogen chloride in it. So we're adding 25 milliliters of this dilute hydrochloric acid solution, which is at 25 degrees Celsius. And we're going to add that to 25 milliliters of sodium hydroxide solution at the same temperature. So we're mixing an acid and a base. This is going to be a neutralization reaction. We haven't learned about acids and bases yet, but it's going to produce water and salt, which is going to be exothermic. It is asking us to calculate the enthalpy. All we're going to do is just use Q equals mc delta T of the surroundings, because all the information we have right now is like the temperature changes is about the surroundings, the water. Let me illustrate what's going on. All right, we have a foam cup and it has both these solutions mixed in it. And so the solution is almost all water, but the reaction is the system that we're interested in. The reaction right here is the system. The water that the acid and bases are in is the surroundings. All right, so the temperature change is given for the water, the surroundings. So we need to calculate the heat absorbed, in this case, by the surroundings. That's what the thermometer is measuring. The mass of the solution here is, I think, is 25 plus 25, so that's 50 grams. Okay, let me go over to the side and explain how I got that. So 25 milliliters was added to 25 milliliters of these solutions, and 25 plus 25, you have a total volume of 50 milliliters. And it actually gives us the density of the solution. Multiply through that by conversion factor, which is 1 gram per milliliter is the density of water, or very close to it. You see that the milliliters cancel out and you just get the same number in grams. Right, so if you're given milliliters of water, you can just say it's the same number in grams. Or if you're given cubic centimeters, which is also a measure of volume, these are equivalent, then you can take that same number and say that's how many grams you have. The C is the specific heat of water, which is 4.184 joules over grams per degree Celsius. And change in temperature is 32 minus 25 is 7. Do final minus initial, right? So this is going to be positive. 7 degrees Celsius is the change in temperature. The Celsius is going to cancel, the grams is going to cancel in. Get a 1,464.4, but we're not going to need all those sig figs. And this is in joules. We can write this in scientific notation. It might be just easier to move the decimal over 3 times to the left, so it's 1.46 kilojoules. If we have 3 sig figs, we can rewrite it like that. Now, this is not our final answer because this is the amount of heat absorbed by the surroundings, and we know this neutralization reaction is a exothermic reaction because it raised the temperature of the solution. The surroundings gained energy. Where did that energy come from? The system. So the reaction must have lost that same quantity. So that positive, we just flip it to a negative, and now we have the system's perspective. So 1.46 kilojoules is the amount of energy that was lost. So that's the change in enthalpy is equal to heat under constant pressure, and this is open atmosphere.